In the last video, we discussed about uh, vectors and matrix, how to enter data into a vector and data into a matrix. The point that I could not cover in the last video is how do we assign value. Suppose I have given matrix and I want to change the values, particular value in a matrix, how would I do? Or I have already given vector and I would like to change a specific value in the vector. How would I do this? So this is first I'll discuss. Then I'll have a little discussion about different types of data, qualitative and quantitative types of data, and how R works with these kinds of data sets. Quantitative data I've already discussed in previous videos in variety of ways, but today I'll focus on qualitative data, which are typically categorized data, either nominal or ordinal format. I'll discuss about how the very important issue in R, which is factor, which is factors are used to identify categorized variables. So how R takes these categorized variables and how to work with factors and how do we convert factor into numerical or character. So this is all the content of today's class. What I'll discuss first is how do we assign, uh, suppose I have identified a particular vector, how do I assign a value into it actually. So to do this, let's first identify a vector. Let's first create a vector x equal to c. I'm using this command c and then some values. Right now I'll simply use numerical values, then I'll change and look at the categorical or qualitative values. Suppose in my assignment of this vector, I have assigned character into a vector, and I think I find, let me first read it. So this is x, which read everything as category. So what does it mean? It means if I calculate mean of x, it will be an error because you can't read these numbers. These numbers are taken as characters actually. So character you can't add up or estimate the mean of character. So it's a bit difficult. What best way is as what we discuss. If we really want to calculate mean, what we have to do, we have to use the command s.numeric. This is what we did last time also, but in different format. Then it will give me, and also there is one more, na.rm equal to true. Then it will give me the value. Oh, it's not giving me the value. Uh, because let me first look at, I'm sorry, I did actually, I assigned na.rm in the wrong way, in the wrong method. I should assign here na.rm equal to na.rm equal to true. Now it will give me the value. This is the value, 5.5. So how do you assign, suppose this is my vector, and suppose I identify another vector as s.numeric x, okay? It will give me a warning that it is, tally it is coursing to NA, but it is converting all other variable or other values as numbers. Suppose I find this NA is by mistake, it's my entry error actually. I would like to correct it. It should ideally, actually it is 11. Instead of NA, it should be 11. So how do I change this number? Now, first what I have to look at is the index. I talked about index last time. So first element will be identified index 1, 2, 3, 4, 5, 6, 7. So X7 is not NA. It is actually 11. So how would I correct it? I'll use the command X, define the seventh element, and then I'll say 11. Okay. So now you look at x7 is 11. Same way I can say y7 is not NA, it is 11. So now you look at why NA is converted into 11. You can also extend your matrix. So suppose you say, okay, the eighth element of y is 23. Okay, so now this vector size will change to 8 and eighth element will be 23. So y is a number of 8 elements and the eighth element is 23. So this is how you can assign values to a vector. Now we'll look at how do we assign value to a matrix. Before that, what we'll do, we'll create a matrix actually. Okay, and we'll use matrix from vectors. So we know vector very well so far. What we'll do, we'll create a matrix from vector. Suppose I have a matrix of 4 variables. The first variable is state. The second variable is population. Third variable is GDP. Fourth variable is you can say typically maybe you can say the area. Okay. So now when we say state, state is a name. You have to understand this. State is actually a name. You can identify. So it is typically a qualitative variable, qualitative data or categorized data. Is it nominal or ordinal? This is the question. I'm posing it to you. You find out the answer. Okay, that's up to you. You need to find out the answer for this. Okay, I'm not going to discuss. I think with the previous classes you are well. I think the background is a good background is given to you. Now population, I am keeping population in millions. Okay, and it's typically a number variable, numeric. Okay, the second variable is numeric. GDP in billion USD, and it is also a numeric. These are I'm cooking up these numbers actually, so don't relate it to the actual numbers. I'm simply cooking it. Area in square kilometer. Also, this is numeric. So in this particular matrix, I have 4 variables: state, population, GDP, area. State is qualitative data or categorized data. Population, GDP, and area are numeric values. Okay. So what I'm going to do is I'm going to create a vector for this. So let me say state. Okay. So state, my first variable is state. Before that, let me actually delete everything from here. So my first variable is state, and I'm simply picking 5 states and giving the first initial name Maharashtra, Karnataka, West Bengal, Punjab, and UP. So these are the 5 states. So what I'm going to do is I'm running this vector. State is a vector which is character of 5 states. Okay. Now the second variable is population, and my population is in millions. So Maharashtra 12 millions, Karnataka 11 millions, West Bengal 14 millions, Punjab 7 millions, and UP 23 millions. Okay, so this is the population vector. I'm creating third vector, which is GDP. Okay. So Maharashtra, the GDP in terms of billion dollars, you can say $25 billion. Karnataka, roughly $18 billion. West Bengal, $14 billion. Punjab's $17 billion, and UP $15 billion. Okay, so that's a way of GDP of different states actually. Now the next is area. So area, which is C, Maharashtra in terms of square kilometer, it would be 200. Karnataka 189, roughly because it's a random number. West Bengal 167. Punjab 112, and UP is typically 195. Okay, so this is the order of area. So now we have four vectors, and I would like to create a matrix. So my matrix mat is, okay, it is the combination of this data set actually. So what I'll do, I'll use the command cbind. Okay, so what cbind is doing is binding vector by columns. That's a C means column bind. So what is doing it? Binding vector by columns. Okay, so let me look at how this works. Cbind, and now I'll bind state. I've already defined state. State my first vector. Be careful with spelling. This is small s. Then population, then GDP, then area. Okay, these are the four vectors which I'm combining and creating a matrix. So all these vectors are bind by columns. Okay, let's look at how this works. So now you have a mat. Now the thing is, mat has 5 rows, 4 columns. So what are 4 columns? State, population, GDP, and area. 5 rows with 5 labels actually. Okay, let us look at how mat looks like actually. I'll double click over it, and I can see how mat looks like: state, population, GDP, area. Okay, so this is your matrix. So I created a matrix. Suppose by mistake later on you realize that the GDP value for West Bengal which I entered, it is not really a 14, it is actually 11. This is the wrong value. How do you correct this? Okay, so you have to remind what I discussed in the last class. In the last class, I told you how do you identify an element of a vector. So you have to give index value, and then it will give us what is the value that is there in that particular index. So what do you mean by index? Index, first is row, the second is column. So what is this index? 1, 2, 3, third row, 1, 2, 3, third column. Okay. So my mat matrix, which is is the name of my matrix. What should I say? The third row and third column is actually 14 instead of 11. Sorry, 11 instead of 14 actually. So I assign this value 11 to third row, third column of variable mat. Okay. Now you look at this has changed. Now your GDP is correct. So you can actually change if there is. You can look at your data matrix again, and if you want to change the value by this method, you can change a value of your matrix. Hmm? So this is a background of how do we sorry, how do we assign a value to a matrix. Now quantitative data we've already discussed. GDP is numeric, it's quantitative. Population is uh, Numeric, area is numeric, all these quantitative, all these are quantitative factors actually. But matrix, mat is not really a quantitative matrix. Be careful with this. Mat is currently a, if you look at, or if you type here, MAT, what you will get, oh, I'm sorry. Let me type mat. Before that, let me clean my console and type mat there. So let us, what is happening? MAT, capital MAT, MAT, okay. Let me not use the prompt. So now you look at the moment, because I have not identified anything, what it has done, it has actually converted all numerical value into character. It is necessary. Suppose I say what is the sum of the area, okay. So what is sum of the area means which column is area, 1, 2, 3, 4. Fourth column is area. So sum of all fourth column. So my met all rows, fourth column. I would like to estimate the sum. Sum of these. At the moment, it will show me error because what I have done, I have not converted these character into numerical values. What I should do in this way? Before that, I should use as dot numeric command to convert into numeric. So it will first what this is doing. Sorry, what this part is doing. This part is extracting the fourth column, all variables in the fourth column, and then it is converting them into numeric. So now it is, let us take the sum of this. So sum of this is 860. So what you have to be careful when you read a data into a matrix, because the type of data that you are entering into a matrix, it will automatically be reading the entire matrix either as a form in form of numeric or character. So if it is character, you have to convert that into numeric before doing any of mathematical operation on it. So that's very important. Next point is I will talk about uh, uh, categorized data. The moment at the moment, state is actually a categorized data because it's a qualitative data actually. Okay, so typically in R there is a feature what we call factors. The factors are the feature that runs categorized data. It can run the ordinal data as well as nominal data. For example, state is the categorized data. State, the vector state is the categorized vector or character vector right now. I can convert this into a class factor. Before that, let me actually look at, suppose I would like to know what is the structure of a particular variable. The command is str. Then I have to define the variable state. Let us look at the structure. So it's a character. Okay. What I can do is, let me define, instead of before when I'm assigning the value of state. Remember how did I assign the value of state? Let me go back to the command. This is the command which I use in order to assign the value of state. Now instead of this, I'm for every entry, what I'm doing, I'm defining inverted comma with each entry. Now suppose I don't use the inverted comma for each entry. Okay, as thought. Sorry, I'll say factor. This is the kind of uh, function, and I don't use inverted comma. That means it is automatically reading this as uh, character data. Okay. Sorry, as thought factor. Let me check it. Is it working or not? No, I need to define inverted comma in any sense. So inverted comma for this, then inverted comma, then inverted comma, then PB as inverted comma, and UP as inverted comma. Okay. Now again, it is, sorry, it should be factor. So it is a factor. Then I have to specify whether it is ordered or uh, nominal. So ordered, I'll say factor. Then I have to specify this as ordered or nominal. Sorry, so if we want to, if suppose we have this variable state, okay, let me check it. Yeah, suppose this we have this variable state, and state is a categorical character variable. Suppose I define a variable y data. So I say, no, this is not a state, this is a factor. The state is not character, it's actually a factor. So how do you define it? This looks like this way. Y data, which is a factor, it has 5 labels. Let me read Y data in console. So this is how. MH, K, WB, PB, and there are 5 labels. Okay. This is one thing which I can do. So the moment it is saying ordered factor, you look at Y data. Okay. This is the factor. And the labels are like this actually. But you keep in mind right now, when I'm saying the default version is the ordered part is false. As I said, if we have a categorized data can either be nominal and ordinal. So the if ordered is false, if this is the default part actually, if ordered part is false, it means your data is nominal. What does it nominal data means? I'm leaving it to you because we have already done, a discussion has already been done. So this is what we mean by nominal and how R reads a nominal data. It reads a nominal data within the version of factor actually. It defines the factor. Now suppose I want to make this ordered data, this factor which is currently nominal into the ordered factor, ordinal factor. What I'll do, I'll instead of false, I'll say true. Capital T is the symbol for true. And then we look at Y data is ordered factor, and this is how Y data looks like. Ordered factor, K, M, H, P, B, and there is an ordering into it actually. Okay, so this is how a factor works actually. For example, let me actually look at, suppose numerical data is being read as a factor. So let me look at this. Uh, then I'll discuss the challenge with factor actually and how do we need to convert that. So before that, I'll again clean my workspace. Suppose my data is population and my new data is X data, which is a factor of population. Okay. Now this is when I'm not saying anything, it means it's a nominal factor. Let us look at what is X data. X data, which is a 5 value, and this is a factor. So let us look at X data. There are so many, each label is different and there is no relationship between each label. That is what we mean by nominal actually. So this is the value. Each value is categorical value right now. And this is an arrangement. If I make this as ordinal, so what I'll say, ordered equal to true. And then I look at ordered factor. And this is how X data looks like. Okay. 7 is less than 11, 11 is 12 is less than, sorry, 7 is less than 11 is less than 12, 14 is less than 23. That's an arrangement. It's a order part actually. Okay, so this is how you read factor in R. Now, what is the problem? Why I'm actually introducing this new term factor? Because right now I'm working with very small data, I'm creating data. In future, we'll be working with outside data. We'll take data from outside sources. We'll load that data in R, and those data set may be very large actually. Depending on what is the content of that data, it will automatically, in many cases, what happens are because you may have number, then you have character, you have character number and other things. So unless you define each and every variable, which typically doesn't happen actually. So what R takes, initial and the initial part, R identifies by itself, it identifies the nature of variable or nature of columns actually. So in many cases it defines nature or the column as factor. Okay, so if it has automatically defined something as factor, it means R is reading that particular variable or data as categorical variable. It can be either nominal and ordinal, one has to look at. But actually the data set was a kind of combination of character and numbers. So what is, and we need to work with the data, we need to estimate some quantifiable parameter from the data. So since R is reading the data as factor, which is categorical variable, you may not be actually uh, estimate any quantifiable parameter like you can say mean, sum, quantile, and other things. So in such cases, it is very important. You need to read the structure of the data, and then there is, if there is any factor which is coming and you want to work with that particular data and do mathematical operation with the data, you have to convert this factor variable into numerical way. Okay, this is very important. So this is how, this is why factor normally get introduced actually. So now suppose this, I'll actually read one data, like for example my GDP. Suppose I'll make some more variable in my GDP. So GDP is earlier GDP plus some, by mistake, some entry error is appearing over there. RE, comma, 3, comma, 4, comma, 90 something. Okay. Now let us look at the GDP variable. It is the character currently because D and RE are the mistake, by mistake it has appeared over there. So it is character. But as I said, suppose it is not character. If R is reading that as factors, what is happening? FGDP, suppose this FGDP variable is, GDP variable is factor. Okay. FGDP, sorry, is factor of GDP. I am not assigning anything right now. That so FGDP is a factor of 10 labels. Now what I want to estimate, I want to estimate the mean value of this GDP value. So as I said, at the moment it will not work with mean value because this is a factor. Okay, so FGDP, if I estimate, it's an error actually. An error, it's showing NA. Warning is argument is non-numerical or logical. Okay, and that's why it's returning NA actually. Or actually there was some data errors, but there were numbers into it actually. Okay, so how do I convert? Hmm? So now if I say uh, fn, suppose a new variable, as dot numeric to my factor variable, which is FGDP. So what is happening? Fn is, let us look at, let us compare the actual GDP which I entered here, which is here, and Fn. Are they same or not? Let's check it actually. Okay, so I'll use the command cbind. Actual GDP is this, and Fn is after conversion of factor into this. Okay, now what is happening when I'm converting and saying, okay, my FGDP is factor, convert this into numeric, it's not really converting in the right fashion. You look at, because it's a label of the data which is taking actually. So that's not a right way of conversion. The right way of conversion of such data is I'm calling another variable fnn. What I should do, I should convert my factor to character first. So how do you convert your factor into character? as dot character. I use the command. And what is my factor? FGDP is my factor. So I'm converting this into character first. Now this whole is character right now. I'll convert the entire character into numeric. Okay. So this is how normally, if I want to convert it, this is how I do actually. Now FNN, and there are some character value which it is converting into by forcefully it is converting into NAs. Okay. Let us check again whether the numbers are coming correctly or not. So instead of Fn, I'll put Fnn and let us check. So 25 is 25, 18 is 18, 14 is 14, 17. Now everything is correct. D become Na, Re become Na by force actually. Okay. So now Fnn is a number which has 25, 18, 14. All these numbers are same. And suppose I want to calculate mean, then my mean is Fnn. But remember there are NA, so it will return NA. So I have to remove NA. So the command is NA.RT. Okay. Now it's giving me the mean value. So the point is when you load a large data set, you don't specify anything. Typically it doesn't happen because R initiate and identifies each and individual variable into a particular structure actually. And somehow R has given has actually identified by default R has identified any variable as factor. There is a need to convert that factor into numerical value. Okay, this is how you have converted your factor into numerical value. So very important part. I'll just write a command, and this is very important command as dot numeric. Within that as dot character character, and you have to give your data. So this is very important command one has to remember. When you have when you encounter factor in R, how do you convert that factor into numerical value? Okay, so this is uh, uh, the content of this video. In the next video, I'll discuss about, I'll give a start initial discussion about matrix, which we have already discussed, but again, I'll discuss. And then we'll move to three important data structure in R, which are data frame and table and list. Okay, these are very important data structures in R, which I'll be discussing in the next video. Till then, bye bye.